Today. Back when we solicited at NASA for scoping studies for the next field campaign, there were actually 3 funded. One, of course, was exports, and that was funded in 2012. And then we funded 2 more exploratory scoping studies in 2013. One is called Arctic Colors. Arctic Colors at this point, if you have not been following it, has submitted a draft science plan that's gone through a public comment period. It's also gone through 1 round of external peer review at NASA. And so what they are doing is, they'll be, Antonio will talk about this, they're going to be holding a workshop this afternoon into tomorrow about focusing down some of the science questions associated with the program. So I would just want to introduce Antonio and Maria Georgiou, who have done a ton of work in corralling the science community and getting together the draft science plan, and further will lead the workshop that will focus the science a little bit more at the request of the external peer review and the public comments. So, Antonio.
Good morning. Can everyone hear me? Okay. So one thing I do want to add is that it's been a team effort. There are 7 PIs involved with Arctic Colors, and all were involved in developing the science plan, as well as a larger team that I'll talk about briefly later. So Paul has already provided the introduction here regarding what Arctic Colors is in terms of the field campaign scoping study. Color stands for coastal land-ocean interactions. It has a dual meaning, ocean color and coastal land-ocean interactions. So our aim is to improve the understanding and prediction of responses of terrestrial fluxes, productivity, biodiversity, and food webs in a rapidly changing Arctic environment, specifically the coastal zone. We also want to assess the vulnerability, responses, and feedbacks of coastal ecosystems, communities, and natural resources to current and future pressures. All right. It's a collective effort by a large team of individuals. Here are all the individuals that participated in the development of the science plan, as well as external additional input during the review phase. Lee Cooper was one of the members of this group, and he's here, and we expect a couple others later today. The aim of this group was to, the objective was to identify the high priority science questions, determine the research study domain, trying to explore opportunities to link to other activities in the Arctic. We've held 12 meetings so far, town halls and special sessions at various meetings and conferences. We held a town hall at Ocean Sciences this past February. In order to develop the science plan, we held 2 dedicated 2-day workshops. They weren't open, they were limited to this group here. But hence why we had the open town halls and special sessions to gather input from the community. So why the coastal Arctic, as opposed to the wider Arctic or another site? There have been significant increase in summer sea surface temperatures in the Arctic over the past 50 years, which has resulted in substantial reduction in sea ice coverage and ice season length. That has increased primary production and changed food web dynamics. During the NASA IceCape project, they discovered these massive under ice blooms. So there are things about the Arctic that we don't fully know or understand just because of the remoteness and lack of resources. The permafrost is thawing. Globally, in the Arctic, there are 1,672 petagrams of organic carbon stored. Just to remind you that in the atmosphere, we only have about 750 petagrams of carbon as carbon dioxide. So even if it's just a small percentage of this is mobilized and released into the atmosphere, that would be huge repercussions for our planet. Coastal erosion is quite substantial, on the order of 17 to 20 meters per year of coastline in the most exposed sites in the Beaufort, about 0.3 meters per year in the Chukchi. And estimates vary. I've seen different estimates from different publications. These are some of the most recent. The Arctic seas are also acidifying as the rest of our oceans, and there are consequences for Arctic wildlife and human populations. So just a brief overview of our timeline for our scoping study. We kicked off in January 2014. We held the team workshop in June of 14 and in November of 14. We posted a draft of our science plan in August of 2015 for community comment. We had a few extensive sets of comments. We revised and submitted the science plan to NASA on September 30th. NASA posted the science plan for a 30-day comment. I'll continue this timeline in a bit, but I'd like to talk about the science plan next, and then what the panel review and their comments regarding the science plan. So here's the table of contents. I'll first start talking to you about the motivation, talk about why NASA, the urgency, the science questions, the overarching aim, the study domain, a little bit about what we were recommending in terms of field activities, and then something about how it might be implemented in terms of the amount of time that might be required to accomplish the goals. Okay, so the overarching science goal that we came up with through this activity and placed into the report is to determine the present and future impacts of terrigenous, atmospheric, and oceanic fluxes on the ecology, biogeochemistry, and ecosystem services of the Arctic coastal zone in the context of environmental and climate changes in the Arctic. Very broad. And so we decided to cast a wide net to make this, to address science that goes beyond the purview of NASA OBB. So that was intentional. And so this is just our little schematic of the types of things we wanted to address, specifically looking at the impacts of hydrological processes, river and river outflow, human activity, permafrost dynamics, the impact of that into the water, landfast ice, coastal erosion, sea ice, under ice blooms, land-ocean tropospheric feedbacks, physical processes such as upwelling, and of course the ecological and biogeochemical processes that are occurring within the water column in exchange with the benthic community. Again, quite broad. We had 5 proposed top-level science questions. How and where are materials from land, atmosphere, and ocean transformed within the land-ocean continuum in the Arctic coastal zone? How thawing of Arctic permafrost translates to changes in coastal ecology and biogeochemistry? How changes in snow ice conditions and coastal circulation influences Arctic coastal ecology and biogeochemistry? How do changes in fluxes of materials, heat, buoyancy from the land, atmosphere, and ocean influences Arctic coastal ecology and biogeochemistry? How do changing environmental and climate conditions alter the Arctic coastal zone's availability and use of ecosystem services? This was a nod to the human dimension aspect, although it was a small leap, not a full, a complete leap in that area. As you can see, these are quite broad. So the study domain. The study domain that we identified is this pink region here, including Norton Sound, portions of the Chukchi and the Beaufort Sea. This extends from the head of tidal influence in the rivers out to the coastal shelf. The main area for our process studies or intensive sites is mostly in the nearshore environment, basically in the within the 50-meter isobath. There was an extended domain which included the Canadian archipelago, the Victoria Island and Banks Island. This would be primarily handled through a collaboration with Polar Knowledge of Canada and their Canadian High Arctic Research Station in Cambridge Bay. So the study domain includes the outflows of 2 large globally important rivers, the Yukon and the Mackenzie, also other regional important rivers that include small tundra rivers, coastal lagoons, and erosional bluffs. We envisioned 2 types of field activities: process studies, where we had intensive sampling and experiments extending from the river mouths out to the mid-shelf for both small and large river outflow sites, plus coastal erosion sites with both lagoons and bluffs. And this is just this just shows the watersheds for some of the rivers that we considered as being important, both high priority and maybe moderate priority. So, and the reason for the selection of these is to provide some contrast in terms of loadings from the rivers and the land continuum into the sea, particle load, sediment, CDOM, carbon, nutrients. Also, the timing of the peak discharge varies among these rivers. The timing of the landmass and sea ice both break up and freeze up differs. There's certainly a large, significant latitudinal gradient between the Norton Sound and the Canadian Beaufort. Also, coastal ice coverage and open water varies. And the watersheds themselves, whether they're boreal forests, just tundra, whether they're mountainous or not, or in soil type, among other things. Complete seasonality is something that we felt was we could not compromise on. We proposed and recommended continuous measurements through floats, buoys, moorings, autonomous underwater vehicles, and remote sensing from satellites. And conduct intensive process studies during key months, which also includes airborne remote sensing. These are some of the 5 time points that we identified and the reasoning behind it. Perhaps late February further south into early March for the end of winter condition, May, June with peak river discharge, ice breakup, under ice blooms. In July, you still have under ice blooms, increasing biological and photochemical activity. September is when we have the maximum open water, minimum sea ice, lowered river discharge and preconditioning for the winter. And then in October, the freeze-up period begins. We proposed 2 complete annual cycles for the highest priority sites, and then 1 complete annual cycle for other sites. Overall, we proposed a 4-year field program, and I'll go into a little more detail later. The other type of field activities were survey studies, essentially to assess the spatial heterogeneity in physical, biological, and biogeochemical state of these different shelf regions. You saw that the domain is fairly large and very extensive, and obviously it's impossible to have assets in the field to measure that extensive region. The survey studies would help us link the interactions between the outer shelf and the shallow shelf regions where we would be doing the intensive process studies. We would be using the survey studies to evaluate model simulations across temporal and spatial scales. The survey studies also permit scaling up of remote sensing observations for both development and evaluation of remote sensing algorithms across a range of environments. Also, it would help us distinguish point sources versus distributed inputs. And there are two periods that we identified as being most critical for survey studies. In part, also the logistics of actually getting icebreakers out there. Also, that's quite critical. Obviously, we're not going to have well, these are the ones we identified as most important. July, August, and September, October for the same reasons that I mentioned in the previous slide. The surveys will be conducted during each year of the field program, so we proposed 4 years. Utilize ships of opportunity when and where possible. And there are a number of scientists that have taken advantage of this over the years. So we described an integrative observational approach. That this would not be a traditional oceanographic campaign with a few oceanographic cruises. No offense to IceScape or exports, the science and the location of what we envisioned requires something different. We need a diverse array of measurements and approaches that are proven in the Arctic for year-round measurements and sampling. And these will vary depending where the measurements will be collected and when as well. So certainly in the winter, early spring time period within the lower river, delta, land-fast ice regions, we'd be using ice camps, all-terrain vehicles, sleds, small boats and small ships when the waters are passable from the lower river to nearshore seas. medium and large icebreakers in the nearshore to outer shelf seas, with deployable small vessels to enable work in the near the ice and in shallow waters. Helicopter-enabled sampling, moorings, floats, buoys, gliders, and other autonomous vehicles throughout each year of the field program, and of course, airborne and satellite remote sensing. Models are obviously critical for this type of science activity. Field studies and measurements will be planned in coordination with modelers to ensure uncertainties and model parameters are resolved. And we had several modelers as part of our larger team. So I showed this earlier, essentially some of the things that are relevant to incorporate into a model. Certainly the physical processes, the ecological, biogeochemical, atmospheric forcing, the land forcing. So we would need coupled terrestrial, hydrological, and 3D numerical models of the sea, including sea ice, land ice. We also want to leverage from above. Above is a terrestrial ecology program, the Arctic Boreal Vulnerability Experiment. And it's in full swing now. Peter Griffith, who leads the project office, is here and can help address questions about above. This is just one of their maps. The red is the outline of their core study domain, and this just shows the research stations and logistics centers that they identified that might be of use for for that activity. And it's started in 2015 and will end in 2024. I believe their last year in the field is 2022. And they're planning airborne campaigns as well. So a little bit about the timeline. I'm not showing the years of what we listed in the science plan just because, well, the timeline has changed. It seems likely that exports is moving forward. So, if exports is happening somewhere in here after 2017, where would Arctic colors fall? It's unlikely that Paula can manage a miracle at NASA and support two large-scale field campaign activities at the same time. Though we don't mind if you try. I'm not sure if she's still here.
I can manage the miracle. I just need it to happen.
So there are some key elements that are taking activities that are taking place within this time frame that are important and relevant for Arctic colors. Above, as I mentioned, the Canadians have funded a Sentinel North, and there's some representatives from Laval University in Canada. They'll be here. I'm not sure if they're here now, but they'll be here later today. It's a 7-year, $100 million program. Some of that resources, those funding, will go into studying the Arctic, both in terms of modeling, field observations, and remote sensing. And we'll hear a little bit more about that later this afternoon. Paula and Mike Barenfeld talked about PACE earlier on Monday. So PACE is a NASA ocean color atmosphere cloud mission, launch of August 2022. I know that Mike talked about the ocean color instrument, and we're all very excited. It's being built at Goddard. One of the other things that we're looking at, there was we're talking to the Canadian Space Agency and Naval Research Lab. They're interested in contributing a coastal camera with 100-meter spatial resolution capability. Hyperspectral capability is very, very similar with the OCI instrument. So that capability would be extremely valuable if NASA approves it and the Canadian government approves it to apply towards Arctic colors. So what did we, in terms of the implementation, what did we suggest? So we suggested a pre-work phase, about 1 to 2 years, to develop data repositories, field, satellite, remote sensing, also modeling output and initial development. Proposed two sets of project phases. Each would be 4 years duration. The first 2 years would, fieldwork would occur during the first 2 years of each. And in these two sets of 4-year projects, there would be fieldwork, remote sensing, and modeling activities. And then there would be an additional 2 years at the end of the second sets of projects for synthesis activities. So overall, this would be an 8-year period. There would be 8-year period with the first 2 years of fieldwork, then followed by 2 additional years of fieldwork from the second set of projects. And then at the end of this 2 sets of projects, we'd have the synthesis phase. So if you include this pre-work, it's essentially a 10-plus year period. Again, obviously, this could be constrained and reduced. We even scoped out maybe what would it cost if we reduced this to 3 years of field work. And so that's something to consider as the realities of budgeting. Budgets will set in. So we came up with a notional budget in the order of 80 million. But that's, again, we try to incorporate everything that I talked about already. And there's a lot more detail, obviously, in the science plan document. About half the funding would go to basically competed science awards. And this also includes about 4 million instrumentation, because some of the instrumentation will be needed, and some of which will be deployed and never recovered because of the nature of the Arctic. Project management is in line with above and what experts proposed. There's about a third for ship time, helicopters, all-terrain vehicles, and so forth. And then the airplane remote sensing was about 10 million was our estimate. This would come from separate NASA airborne programmatic funds, not from research funds. So just to give you an idea of what we think is the scale of this, certainly we had a D-scope that was smaller, and there, obviously, you could focus on different aspects and reduce this further if that is the limitation budget-wise. So what's the urgency? There was a new terminology recommended by Jeffries et al. In 2013 documentation of a new normal in the Arctic. The biophysical changes in the Pacific Arctic region are becoming extreme compared to the recent past. So the past was the normal, now we're in the new normal, and then there'll be the future. What happens in the future? The sea ice loss during summer is 50% by area, 75% by volume in this region. Light penetration has increased. You have higher net primary productivity, analyzed for this time period shown there, especially within the interior shelves, Beaufort, Eastern Siberian, but less in the Chukchi Sea. Kevin Arrigo et al. And Simon Belanger et al. Have estimated increase in net primary productivity on the order of 20 to 30%. That's the low end, and it's actually much higher, much higher. And this is just this does not take into account the under ice blooms. The surface sea layer is experiencing more warming, which is delaying the freeze up and accelerating the sea ice retreat. There's a greater than 50% increase in transport across the Bering Strait over this first decade in 2000. Multi-year ice has almost entirely disappeared. We've also detected recently strong easterly winds in the eastern Beaufort. It's resulting in the advection of warm, fresh water from the Mackenzie River plume. So a change in some of the physical circulation. Arctic ecosystems are shifting from benthic to pelagic dominated. And I see that Jackie Grandmeyer has a talk on the benthic communities later this morning. Why the coastal domain? Eddie Carmack et al. Proposed this riverine coastal domain hypothesis, that there's a contiguous, not necessarily connected, that it's not continuous necessarily, but it's contiguous flow of an airstream of fresh water flowing along the coast from the Bering into the Chukchi and from the Chukchi into the Beaufort. They also suggested that this is likely a pan-Arctic phenomena, but for our purposes, we'll focus on just the Pacific Arctic region of interest. And the surface circulation sort of support this from our Alaska coastal current, Norton Sound, into the Chukchi and into the Beaufort. The Yukon and Mackenzie River outflows provide seasonal pulses of warm, fresh water to the northern Bering and Beaufort seas, respectively. And also there's a comment that the Mackenzie outflow can trap both nutrients and prey organisms, which have implications for both ecological and biogeochemistry. The Mackenzie outflow has increased dramatically over the past decade. Also, the Sag and the Colville River seasonal discharge has increased, suggesting more impact in the present and future than in the past. Also, the thawing of the permafrost, along with changing vegetation on land, will undoubtedly alter the composition and fluxes of organic matter, nutrients, and sediments entering the nearshore and coastal seas. It's also, this coastal domain is not as well studied as the offshore regions. Part of it is just the logistics of doing this, and that the larger vessels are quite effective in more offshore regions. Why NASA? Remote sensing from satellite and airborne platforms are essential for capturing the spatial and temporal variability of the Arctic coastal domain, both in the past and the present. I mentioned you've seen the extent of the study domain. Remote sensing is essential. There's no way you can do this, just address the science questions simply with field observations. NASA has the satellites, airplanes, airborne sensors, and remote sensing data processing and distribution capability to enable Arctic colors. This is just a listing of some of the satellite instruments that can be used for ocean color, both past, present, and future. And there are other satellite sensors that can be brought to bear. And also, we would also bring in airborne sensors as well. We estimate that by the conclusion of Arctic colors, we'll have 30 years of satellite ocean color observations starting with CBIS in the fall of '97. So that's a quite extensive time series. The development and parameterization and robustness of models are necessary to address the goals of Arctic colors will be accelerated with remote sensing observations. I envision this as essentially a three-legged stool. You have to have the field observations, you have to have the remote sensing, and you have to have the modeling. Without one, then the stool falls. Synergies with above and other NASA field campaigns and modeling programs is extremely beneficial to the success of the program. Also, NASA coordinated activities in collaboration with programs and scientists in Canada can make significant progress on Arctic colors goals. And we've begun making those linkages, both with Sentinel North and with Polar Knowledge, as well as other Canadian scientists who were part of our larger team. A more complete understanding of the Pacific Arctic coastal zone is possible with complementary efforts supported by NSF, NOAA, BOEM, USGS, North Pacific Research Board, DOE. Did I forget anybody? So back to our initial timeline. So NASA reviewed the science plan in November of 2015. We received the panel summary just before Ocean Sciences in February. The panel commented that an Arctic coastal experiment represents an important and timely opportunity for NASA because of the rapidly changing Arctic environment. They concluded that Arctic colors is a potential high merit, but needs further study and planning to resolve science or other issues. So they requested revisions. And here are some of the recommendations. I alluded to the broad nature of our overarching goal and science questions. They said we need more specificity in these things. They weren't certain whether we were aiming for fundamental ecosystem processes or carbon budgets. And we were aiming for more fundamental processes. And the top level questions needed more focus. They suggest that we identify the most important ecological problems or biogeochemical processes and what measurements would be needed. Stronger linkage to the past and ongoing work in the Arctic. More detail on the risks that would impact the ability to actually accomplish the project. And also, they asked that we expand on the synergies with other programs that would mitigate risk, like working with above, Polar Knowledge, and so forth. They also wanted a more traceable science traceability matrix. Basically, they wanted it to be modular so that, well, we only have so much money, so let's pull this piece off, or this other. So what's next? One of the other recommendations of the panel was to convene an open community workshop, which is what we're doing later today and tomorrow, thanks to the help of Heather Benway and Mary Zawrowski in helping us coordinate and plan this. Very much appreciated. And the other members of the OCD office. We will once we get input from the community, both from this workshop and afterwards, we will revise the science plan and submit to NASA by December. NASA will conduct a programmatic review, and if that's successful, they will solicit for a science definition team to develop an implementation plan. For example, Exports has now released a draft implementation plan. So they were funded 1 year later, and we're about 1 year behind, and 1 year behind in terms of where they are. We've revised the overarching science goal to quantify the biogeochemical responses of the Arctic nearshore ecosystem to rapidly changing terrestrial fluxes and ice conditions. We believe we must establish a baseline, both past and present, so the normal, the new normal, and then study and predict changes into the future. Again, the workshop that we're holding. So we'd like to get feedback from all of you regarding our new overarching science goal and the science themes and questions that we've begun to develop. Which ones are most important? Which ones are less important? Our hypothesis that it's not too late to establish a baseline for characterizing the conditions in the nearshore Arctic. So the themes that we've developed is, what are the effects of rivers thawing permafrost and coastal erosion on the sea? What are the effects of ice, including snow, landfast, and sea ice on the sea? Also, what are the effects of future warming land on the sea and future melting of ice on the sea? The first emphasis will be the seasonal and triangle effect, and then in the future, use models for future scenarios and predictions. So this is the first theme. These are the series of science questions on the first theme. How does variability in riverine fluxes affect biogeochemical transformations in the nearshore zone? How freshwater carbon, nutrient, sediment loadings to the coastal zone change as a result of permafrost thawing? How freshwater carbon, nutrient, and sediment loadings to the coastal zone change as a result of coastal erosion? And is the relative magnitude of inputs from rivers thawing permafrost and coastal erosion changing across the coastal Arctic seasonally and triannually? Again, the themes are rivers, permafrost, coastal erosion, and then the temporal domain. Effect of ice on the sea, how coastal snow and ice cover impact net ecosystem productivity and control, and by controlling the rates of transport and mixing and modulating light availability. What controls do ice and snow conditions impose on terrestrial fluxes into the nearshore environment? And the seasonality of things. How does the timing of the sea ice formation, retreat, et cetera, influence the coastal ecology and biogeochemistry? And the third theme, what is the future biogeochemical response of the Arctic nearshore ecosystem to rapidly changing river input, permafrost, and coastal erosion? What is the future biogeochemical response of the Arctic nearshore ecosystem to rapidly changing sea ice, landfast ice, and snow? And how would net ecosystem productivity in the Arctic nearshore environment respond to changing scenarios of terrestrial fluxes and ice conditions? So this is our website, our email contact, or you can contact any of the PIs by email. This list, we have a list that I can send out to the entire group. Programmatic questions, Paula Bentempi. There was a whiteboard here from yesterday that pointed out that for exports, it's important that NASA headquarters gets input about Arctic colors, that the community is interested and excited about certain aspects, whether which science questions are of greatest interest, that they feel that this is a worthwhile activity. In that respect, it would be beneficial to contact Jack Kay and Mike Filik. I'm going to leave you with a couple comments that those who live in and work and engage with the Arctic have the most at stake in this changing environmental context. Their input will be sought early in the research planning to inform and refine critical research targets during the field program, and later to ensure that the findings are communicated effectively and broadly. I think one of the things that I've taken away from this activity is that that obviously the Arctic is changing. There are people that live there or work there, and they're going to be most impacted. But the changes in the Arctic will impact all of us and everyone on this planet. So we'd like to transition to a discussion session, but I'll be happy to take questions prior to that. During the workshop later today and tomorrow, we'll go into all of these aspects in more detail and some other topics that I didn't have time to cover today. So thank you for your attention.